All right, so welcome back to the Generative AI in the Real World podcast with O'Reilly. And our guest today is Matt Welsh of Aryn AI. Their tagline is Quality ETL for Unstructured Data with only a few lines of code. So, welcome to the podcast, Matt.
Thanks, Ben. Nice to be here.
And quick trivia for our listeners if you go to Matt's Wikipedia page, and I quote, he was portrayed by the actor Brian Palermo in the movie The Social Network because he was Mark Zuckerberg's teacher at Harvard. And then, according to Wikipedia, Matt was paid $200 for his PowerPoint slides, which were used in the movie. So I'm fact checking Wikipedia in real time, Matt. Are
Yes.
both of these true?
Yeah, so I spent about 8 years as a professor of computer science at Harvard and taught operating systems there. And one of the students that I had in my class, one of the many amazing students I had in my class was Mark Zuckerberg. And this was before he started Facebook, or it was around the same time. I think maybe he started it during the semester that I was teaching. So needless to say, he wasn't in class all that often. He was a bit busy with other things. And, some years later, after Facebook had taken off, I'm sitting at my desk at Harvard and I get a phone call, and it was someone calling from Columbia Pictures. And they said, we're doing a movie about Facebook. It's an Aaron Sorkin film. He wants it to be extremely realistic. And so we're looking for lecture notes or slides or something that we can use in this one scene in the film that you might have used during that time period. I said, I'd be more than happy to help with that. And then later on, they said, well, we have to pay you because it's a requirement that we, compensate for your time. And they paid me $200 to use my PowerPoint slides in the Social Network movie.
You should have asked for residuals.
I know, exactly. I really wasn't thinking at the time. I should have had a better lawyer look at that agreement.
All right. So our topic today is, I guess, the changing nature of programming. So I guess you're one of many people. Andre Karpati is another who've argued that programming, as we know it, it's over, right? So,
Yeah.
So what will replace programming, and how are programmers? What are programmers doing today, and what will they be doing, let's say, 2 years from now?
Yeah, well, I mean, I think, we're in this really interesting time of transition. I mean, first of all, of course, programmers are heavily using AI to help them write code or help them manipulate code, right? So things like Copilot, I use Copilot all day, every day, and couldn't imagine coding without it now. But that's not even what I'm talking about. What my view is that ultimately the idea of sitting down and writing a program in a language like Python or TypeScript or Java ultimately gets replaced by telling a language model what you want to do in a natural language like English. And then the language model doesn't generate computer code. It just goes and does the thing directly. So if I ask the language model, look, I want you to go and scan through all of these documents and identify the documents that correspond to certain features that I'm interested in, and then make a report with this information and these tables, and then fetch this information from this third-party site and incorporate that. The language model can just operate as a somewhat autonomous agent and do all of those actions directly. So not first generating computer code and then you run the computer code, but instead just directly doing the computation using the model.
So these are for one-off tasks, right? So, but imagine if your task is to build a pipeline, then maybe you will ask it to write code that you can inspect and look at, right? But but even the thing you described, I'm not sure if we're quite there yet, because how do you trust that it's doing the right thing, right?
Right. Yeah. So there's an interesting set of trade-offs and challenges here. So What I'm personally inspired by is the idea that I can now write programs, and I'm going to use programs with air quotes around them, that do things that I could never imagine doing before. So to give an example, if I have a transcript from this podcast, for example, and I wanted to manipulate that transcript and lift out, say, summaries of the key topics, or find the bios of the speakers, or go and find references to research papers that are relevant to what we're talking about right now. I couldn't write, there's no way to write that as regular computer code, right? There's no algorithm I could write down. There's no Python program I could write that would do all of those things. And so we're already seeing the idea that using a language model as something that you can instruct, and the language model can manipulate and deal with extremely sophisticated, complex information in natural language, is like really opening the aperture of what computing is all about. Computing used to be about ones and zeros, and then it became around, numbers in spreadsheets, and then it became around, HTML documents on the web. And now we're opening it up to really be able to perform meaningful computation on really any human generated content. To me, that is such a huge opportunity. And I think when people ask the question, well, how is AI really going to influence the future of computing? I can't trust it, or it's slow, or it's expensive. I think they might be often missing that really important point, which is there's a whole new field of kinds of computation that we can now do that you could not do before.
And also, what you're describing changes the persona of who does programming, right? So for a long time, people have been talking about digital humanities, but then that turned out to be humanities
Mm-hmm.
PhDs learning Python and learning how to write crawlers and things like that. But now, from what you're describing, I can be a humanities PhD student, and I could be doing a lot of things that computer scientists would be doing in some ways, right?
Yeah, I mean, I think, since, the 1960s, we've seen this pattern emerge where people in fields like medicine or science or law that needed computation, they'd have to go and ask the computer programmers to do the thing for them and to figure out how to do it. Over time, that's become easier. And, just a simple example, Excel as a spreadsheet has opened up computing to vast numbers of people, because anyone who can put something in a spreadsheet can now build simple computations around whatever data happens to be in the spreadsheet. I think we tend not to think of that as programming, but it really is. I mean, we're instructing the computer how to perform operations on our data. We're just not doing it by writing code per se. We're putting in formulas, but that's fine. It's the same thing. But now what we're seeing is kind of an evolution away from having to go hire that expert programmer, computer scientist to translate my idea into reality. And countless people that I've spoken to in fields in the humanities and medicine and law and other places are finding that they can really get something like ChatGPT up and running and doing a lot of this stuff for them directly. It's faster, it's easier, it's a lot more iterative, because you go try to find, say, if you're in a university medical department and you need some custom program to do something, good luck. Who are you going to find to write that? Maybe there's somebody around the corner who knows how to write some Python code, but they're not professionals. Maybe you can find an intern, undergrad, computer science undergrad for the summer, but then they leave after 3 months and you're left with whatever they wrote or didn't write. So we're finding this opportunity where AI models really are able to unblock people in fields that require computation, need to build software, but really just don't have the expertise to do that. And to me, that's a huge opportunity to enable that, because, you know, all of the sciences, for example, have been revolutionized by computing. But there's still a bandwidth problem, because the number of people you have that know how to do programming and know how to translate the, you know, particular kind of thing that the scientist wants to do into working computer code is very small. It's vanishingly small. And, you know, the best people at that go off and work at, you know, Facebook and Google, not, you know, University of Arizona.
Right, right,
So
right.
it's very difficult to get good talent in many of these fields. But AI is, I think, going to democratize that very much.
Yeah, I find when I'm writing code, I get by with Copilot or maybe one LLM, one specialized LLM. But when I'm doing kind of analyst information extraction kind of work, I end up using like multiple LLMs in kind of an ensemble way, because
Mm,
there's still that kind of trusting, right? So I'm gonna go through a bunch of PDF files with this LLM and this LLM and this LLM. Let's see what the consensus kind of emerges,
right.
because it's a one-off type of task that I want to get right. So I'm willing to go through that pain. So with that
Hmm.
long-winded description, Matt, so what is missing right now from the current tooling and stack to
I
carry
still
forward
think,
what you're describing? Yeah.
yeah, no, exactly. I really think, first of all, it's just way too hard for people that don't have programming ability to integrate language models into their workflows. And that's starting to change. You know, you've seen, you know, Microsoft, for example, is building their Copilot capabilities into lots of their products. And I think that's extremely smart, because it just integrates it right into a place where a business user is going to want that. So ultimately, all of this AI tech needs to be much more tightly integrated into products that people are using every day. Ultimately, that's going to be part of their operating system directly. The OS will understand everything that's happening on their screen. It will be able to understand every application they have installed. It knows how to use the application just like a human would. You know, right now I'm using Rewind on this computer, which records my screen and records all the text on the screen and allows me to go and ask questions and find things that happened in the past. It doesn't make changes. It doesn't manipulate my environment, but I think the next version of Mac OS or Windows should have that kind of capability. So I think what's really missing is that deep integration with people's workflow and people's computing environment, so that it's not a specialized thing. Oh, I've got to go figure out how to run Olama and what is the JSON format of the prompt messages to send, and then how do I get the data from my Word document here into that? Like, none of that is the right way to do it. It's the only way to do it today.
Yeah, I think that the kind of the first iteration will be, as you described, embedding it into the tools that people use today, so spreadsheets. And I
Mm-hmm,
think
mm-hmm,
the other class of tools are these block-based document editors like Notion are starting to
mm-hmm.
embed this capability, Google Docs. But I wonder if any of our friends in the UX interface community are imagining new ways of implementing some of these things. I mean, do you know this guy Brett Victor? He used to kind of create these videos where he would be programming. It'll
Oh,
be
yes.
interactive. Yeah, yeah, yeah. So I
Right.
mean, I'm not saying that that's what I'm thinking, but surely there's also innovations in the UX side
Yeah,
around.
minority report or something like that. Um, I do think, I have the benefit of having been around for quite a long time, and having seen the PC revolution, and then the web, and then mobile, and now AI. So I feel very fortunate to have lived through effectively four revolutions in computing. And, what's coming next is always hard to predict. But I do think we are at that point right now where we are very embedded in the kind of web-based, desktop-based, mobile-based way of thinking about computing interfaces. which goes way back to, things like Windows and the first Macintosh. But AI capabilities do radically change the way that we think about interacting with computers. And, I think voice interaction is one that is particularly interesting, still challenging, but I think the capabilities of AI to handle voice are radically improving. My previous company, Fixie.ai, is now working on building language models that do direct voice to voice. So there's no translation from voice to text and then put the text through an LLM and then you spit the text back out to a speech synthesizer. Instead, it's direct waveform to waveform models. And the benefit of that, there's two benefits actually. One, the first benefit is the latency goes way down because you don't have multiple translation steps. And for voice interactions, latency is pretty important. You need to have it to be a natural conversation like you and I are having. You can't have these awkward, 10-second pauses. The second is there's a lot of information encoded in speech, in voice, that you will miss if you just turn it into text. And that includes, of course, things like intonation, pauses, corrections when I say or I fix something that I said a moment ago. If you just gloss over all of that, you're losing a tremendous amount of useful information. And that information is very important for people to communicate. Anyone who's ever said, look, I'd rather talk about this face to face than do it by text knows what I'm talking about. So I think that's going to be one key piece, is the idea that I really should be able to, talk to my computer. If you remember the Star Trek 4, I think, when they go back in time to the 80s and Scotty tries to talk to the Macintosh, thinking the mouse is a microphone. I'm reminded of that, but I do think that that's really where this is going to go.
Yeah, actually, this reminds me of a team of a company I'm advising called Meaning.team. They do real-time speech synthesis where, I guess one of the applications is just accent softening. So you can turn the knob, right? So do you want to be, if I still had a strong Filipino accent, it can ask me, do you want to be 25% more American sounding, 50%, 75%? They found actually no one wants to completely remove their accent.
Right.
So they had to give people settings. But the
Interesting.
amazing thing about it is what you said, is they can do this all in real time. You can talk to someone like now on Zoom and you won't even notice that this thing is happening.
Well, I trust your podcast producers will definitely use this tool after we finish this recording. And please give me the voice of James Earl Jones or someone like that. I would love that.
I've seen them demos with Morgan Freeman. Yeah.
Yes.
Yeah. So what about, Matt, programming itself? Are you following what how programmers are doing their job now compared to what they were 2 years ago? So
I think that's really changing radically. And at Fixie, we mandated every employee there actually have access to Copilot and use ChatGPT anytime that they wanted to ask questions. I use ChatGPT at least half a dozen times a week when I'm working on a programming task and I'm not quite sure the best way to do something. I can kind of figure it out by looking at the documentation, and sometimes Copilot, through the context of what I'm doing, will tell me what to do. But a lot of the times I'll just go to ChatGPT and say, look, I've got a XML document. I'm trying to parse it in Python. I want to be able to manipulate it in the following way. What's the easiest way to do this? And in the past, I would have maybe Googled that and maybe found some things on Stack Overflow that were relevant, but more likely than not, I would not have. Or I would have, turned my chair to the, person next to me and asked them what they thought, but a lot of the time they may not know. And now that we're working from home a lot, I don't have that freedom. But ChatGPT is there for me. And what I mean is I can ask it really dumb questions and it doesn't mind. And I'm not feeling like I'm wasting someone's time, bugging them with this thing or posting on Stack Overflow and waiting 3 days to get no good responses. So I can really go and unblock myself with that. So given how complex programming is and continues to be, and it's not just learning a language or learning an algorithm, it's always about how do you plug X into Y?
Yeah,
How do I?
some API. Like for example, for
Yes.
me, right? So I have no problem with SQL. I can remember. I mean, I know how to write SQL well, but Pandas, I can never remember anything in
Oh
Pandas.
God, nobody can.
Which brings me to the next question, right? So I use one of these tools, ChatGPT or Claude, right? So to write this out for me in Pandas. It writes it out for me in Pandas. Now,
Oh yeah.
if it's equal, I trust that the database will optimize whatever this thing is, right? But Pandas, how do I know this is the best Pandas code that
Right.
you know what I
Right.
mean? So,
Right.
so which
Right.
brings me to the next question of testing and QA in the world
Hmm.
of where you're just describing essentially at a high level this is my program. I'm building it block by block by prompting, right? So what is testing in this world? I guess you can also use the LLM to write out your unit tests, right? So
Yes, exactly. Well, and I think this is a place where, people will struggle for a while to figure out what's the right set of trade-offs to make. There's on one hand a opportunity to just really move fast and recognize that sometimes, writing not the best code or not the most efficient code or even not even the most correct code is perfectly acceptable if it's allowing you to move quickly, and then you can always fix it later if it becomes a problem. Not all organizations can afford to operate that way. That's common in startups, much less so at, say, a bank. I think the other side is we're not throwing out all of the human processes that we've developed over the last 30 years to help people build reliable software. We still do code reviews. We still write tests. We still, read and evaluate each other's code. If somebody were coming up with, say, not great Pandas code and sending it off, hopefully there's someone that's reviewing that, and hopefully there's someone that's reviewing it that knows Pandas better than the person who had to rely heavily on ChatGPT. Um, but also, more often than not, I personally find that the AI does a better job than I probably would have done, and that my code reviewers would have done. It's not always true. It certainly requires a certain amount of background knowledge to know that you're getting good answers. To give an example of this, an open loop version that I've seen recently is there's a company out there that has used an AI to generate thousands and thousands of blog posts about how to do X with Y. So, how to use Ansible to install Python or, whatever the thing is. And and they're doing this for SEO reasons. I was trying to figure out how to do something. I was using Google to hopefully find an article that would explain the particular set of things I wanted to do. And I stumbled across this blog post, and the blog post is well written and it sounds very definitive. It says, this is how you do it. And so I said, great, that's exactly what I need. And so I spent, half an hour putting it in, going through the steps, only to discover that actually, no, this library doesn't do any of the things that this AI generated article claim it can do. And I was furious because I'd been duped effectively by someone who wrote or had an AI write a very sincere sounding and, reliable sounding blog post on, oh, here's the recipe you need to follow. But clearly that was completely made up. No one had ever actually done this, and it's not even possible to do it that way. So I think that's going to become a challenge over time, is knowing whether the sources of information are trustworthy. Because then those AI generated articles that I was stumbling across on the web are undoubtedly going to be used to train the next generation of the AI model. And so if AI models are seeing blog posts saying that, yes, it is absolutely possible to do this thing with Ansible, that's actually not true, then the AI models have no way of separating the wheat from the chaff.
Or I guess if you're within a company, I don't know. I'm just spitballing here. If you're within Google, Google's vacuums all of Jeff Dean, Sanjay Gemawat, Rob Pike's code, Guido van Rossum, trains a
Right?
model, and this now becomes the mentor for all junior
Yes.
engineers
Right.
inside Google. But it's proprietary because
Mm-hmm.
it can only be used within Google. But every company then can kind of scale their best engineers and
Mm-hmm.
programmers as mentors for their junior developers, right?
I would love that. I was at Google for about 8 years, and if I had had a virtual Jeff Dean, that would have been amazing.
But I don't know if it should be possible now. I mean, it's basically fine tuning one of these models specifically with data that you have from the work of your best people. Fine tune the hell out of a model, and
I
then
think that that's a very smart thing to do. And so right now, we're being sloppy as an industry. We're slurping up whatever data we can get our hands on and using it to train models and then regurgitating that out in various ways. Curation of best practices and curation of good code and curation of good documents, I think is going to become very important over time in order to get the quality where it needs to be. It's not just more data, it's got to be better data. What I really want is a system that understands, for example, that this is really good, solid code and it's high performance. It's well tested and it has, good naming conventions and it has good comments and documentation around it. I want the AIs that are helping me write code to be derived from code that follows certain standards. And I'm not aware that that's happening yet because we mainly benefit from the scale of the models. But at some point, I think the quality of the input data is going to be more important.
yeah, like if you're within Google, whatever their version of GitHub is, has all of the discussions around the pull requests and you know all of these things, and then that might be informative, right?
That was my first startup idea, was to build an AI. When I started Fixie a couple of years ago, the original idea was to build an AI that could automate code review, and not necessarily to replace human code review, but to augment and to remind the person doing the code review or the person writing the code, hey, I noticed these issues. You might want to address them, sort of to get a real time feedback on your code before you sent it to a human, because a human code reviewer is a very expensive thing if you think about the number of hours it can take to review code. So you'd like to have an AI code reviewer that you can work with and catch all the little silly things before you get a real human expert to read it over. We ended up pivoting away from that idea. There's now, I think, a lot of interesting products in that space. But I still want that. I still feel that, asking my colleagues to manually review my code feels antiquated, even though I don't have a great replacement for it yet.
All right, so let's pivot a little to, I mean, still related to ETL for RAG frameworks.
Yes.
This is really up my alley here, man. So talk to me about what Aryn is doing, and so ETL for RAG frameworks. Okay, so I haven't read your website, so I'm assuming let's say I have 1,000 PDF files. You're gonna help me extract information from those PDF files. If I need to use OCR, you have some OCR tool. If there's tables in there, you'll figure out the tables, and then you'll figure out chunking, and then you'll figure out embeddings. What else?
Yeah, so let me take a step back. So, to date, when people have wanted to use AI models to ask questions about their data, they've largely been starting with, I think, fairly simplistic techniques that might take a PDF or a Word document or a web page, turn it into some text format, markdown or plain text even, and then kind of naively break that thing into little chunks, generate an embedding for each of the chunks, and then use a vector database to store each of those chunks and the associated embedding. Then at the query time, of course, you're asking a question, and then the language model is asked to go and consult the vector database, find the most relevant chunks to the query, bring them back in, and then feed those back into the prompts for the LLM to consider when it's answering the question. That's RAG in a nutshell.
Mm-hmm.
The problem is that RAG actually doesn't work that well. It works reasonably well for, I would say, some simple queries where the answer is in a few chunks of context that you can sort of cherry pick out of your documents. But more often than not, that's absolutely not what you need. And so what we're doing at Aryn is we're building, I would say it's a next generation framework for thinking about how to use AI to extract and understand the content of unstructured data. When I say unstructured, I mean things like PDFs and Word documents that there is structure there, but the structure may not be evident from the content of the document directly. So if you look at a PDF file of a financial report or a maintenance record for a piece of machinery or for interview notes for a job candidate or even a resume, there is structure, right? You'll have titles, you'll have headings, you'll have tables, you'll have lists, you'll have figures with captions associated with them. You'll have data in various forms. But we've rendered out all of that structure and put it into effectively a PDF or a Word document that's losing a lot of that semantic structure that was maybe originally there. So the first piece of Aryn is how do you extract out the structure that's inherent in those documents that is maybe has been lost. And for this, we do a couple of different things. The first is we have a very interesting AI model that you can feed it things like a PDF, and it actually just looks at the images. It doesn't need any of the metadata that's in the document. It just uses literally the pixels. And using the pixels of each page of the document can do things like segment out tables, headings, sections. An example, if you have a table that spans multiple pages of the document, the headings on the table only exist on the first page typically. Second page, third page of that table don't have the headings anymore, but the data's there. If you do a naive chunking strategy, you don't have any idea of what this table is and what the content is beyond the first page. So our AI model can do this, what we call partitioning of the document. The second interesting piece there is a framework in Python that we call Sycamore that allows you to build an ETL pipeline using these AI capabilities. So let me give an example. One of our demos is pulling in data from NTSB incident reports. This is the National Transportation Safety Board. Every time that there's, like, for example, an aircraft incident, whether it's a crash or someone taxis off the runway or whatever, you get this PDF file, sometimes many pages, with lots of detail about what happened that's being published by the government. But there's no structure to it. It's just a PDF. It might have tables and lists and things. So the first step is do that partitioning through our AI model. So you're getting back some of that structure. But then you still need to do other kinds of processing in the ETL pipeline that might need to use AI. Simple example is normalizing things like location information. If there's a field in this document that mentions where something happened, there's many forms that could take. It could have a city name.
It's like an entity resolution.
Exactly.
Yeah.
So it could be city name, state abbreviation. It could be city name, full name of the state. It could be latitude, longitude. It could be something else. So using AI, we can then pass over this data again and turn it into something that then is clean, solid data that we can use for later stages of processing.
Yeah. So the thing about RAG is it turns out, as you described, there's actually a lot of knobs you can turn to make it better, right?
Mm-hmm.
from every step. The information extraction is the most underappreciated and underinvested step because people just kind of farm out. Okay, there's 30 PDF extraction libraries in Python. I'll just pick one. Well, how do I know that's any good, right?
Right,
So,
right,
uh,
right.
and then I think at least people now are playing with chunking, right? So, and then it turns out chunking is more impactful than the embedding model that you use.
Mm-hmm,
But
mm-hmm, mm-hmm.
and then of course there's the information retrieval, right? So that's a whole field in itself, right? The ranking, re-ranking, all of this. Uh, but there's a lot of knobs to turn, and the the challenge is that you might get something that kind of looks like it works, and you think you're done, right? So
Mm-hmm.
there's enough of a taste of victory that people kind of think that they're getting the most out of their data, but actually you're
Mm-hmm.
leaving a lot of the on the table unless you probably use one of these tools that Matt is describing.
Right. Effectively, on the retrieval side, simple RAG queries, even if you've done all of this fancy ETL stuff, RAG as a technique doesn't generally work for things that, for example, if you need to sweep over all of the data and calculate aggregate statistics, you can't do that with RAG. It's just not going to work. You'll get the wrong answer more often than not. So
But
the other piece of
the LLM will still give you an answer.
it'll give you an answer. It'll be the wrong one, and that's part of the challenge. So the other part of our stack is what we call LLM powered unstructured analytics, or Luna. So Luna is, instead of
This is
using
great.
RAG, it effectively takes your query, turns it into a query plan, not unlike a SQL query, and generates a structured query that runs against your data using those fields that we extracted from the ETL process. That has a couple of nice properties. The first thing is it's right more often than not. The second is it's something you can actually go and validate and understand what happened during the query execution. So if I want to look at, okay, hold on a minute, I asked you to show me all of the aircraft incidents in Washington that involved weather. I can inspect the data that's been flowing through this query pipeline and understand, did it give me the right answer? Did it include the right things? Was there noise in the data? Was there missing data? In a way that you can't really do with RAG. RAG is a little bit too much of a black box in most cases. But having these structured query plans makes that kind of thing possible. So in my mind, this all kind of comes back to this question of, what's the future of programming? It's the idea that we're going to use language models as little computers, or big computers, as the case may be, to perform computation that would be difficult to express in just a conventional programming language. And in this case, we're applying that idea to the question of how do I perform analytics on large amounts of unstructured data? And it's a great fit because it's something that the LLM tech is really good at, but you have to put the LLM tech in the right part of your stack. You can't just use it in a kind of naive way. You have to build around the LLM in the right ways.
So, Matt, one of the hot topics in the RAG area is graph RAG. I don't know if you've heard of
Yes.
that's a
Mm-hmm.
graph RAG is basically there's no single design pattern. It's basically anytime you involve a knowledge graph as part of RAG,
Yep.
then you can call it graph RAG. Um, but obviously, the challenge is who has a knowledge graph, right? So the automatic knowledge graph construction tools need to get a little simpler and better, and maybe
Yes.
more accurate, because
Right.
there are tools out there, but if it gives you a bad knowledge graph, then what good does that do you
That's
anyway,
right.
right? So it sounds like you guys might be able to help with some knowledge graph construction, given that you're extracting so much out of the data, right?
That is exactly right. So one of our projects is something where we're effectively doing knowledge graph construction from the unstructured data through this Sycamore platform, and then exploring how the knowledge graph could be used then in improving the query results. However, it may be that what we find is that it's not necessary to have a knowledge graph in order
Right.
to get really good results once you've gotten the right kind of underlying structure to the query operations. So it kind of remains open question, do bringing in knowledge. I agree that in a kind of simplistic RAG framework, knowledge graphs are incredibly helpful. But when you start doing these interesting structured queries on the data, I'm not sure yet that you need a knowledge graph in order to get good results. So it's an open question, and it's something we're definitely looking at.
I think to me the thing that passes the smell test is getting any kind of structured information out of your unstructured data, because very early on people obviously realize right away, look, even metadata, because I can do metadata filtering,
Mm-hmm,
right?
mm-hmm,
But
mm-hmm.
then the knowledge graph, as you say, you may or may not need it, but the fact that the Sycamore tool is able to identify some more structure out of your unstructured data is
Yep.
going to be helpful, I believe. I mean, I don't have any evidence, which brings me to my closing question here, Matt, which is eval, which is
Yes.
eval for RAG, but eval in general in this new world, because we now are in a world where it takes me 5 days to build an interesting AI app, and then my lawyers tell me I have to test it for 10 weeks, right? So then it seems like the eval tools are a little behind the development tools. Am I wrong?
Oh, absolutely true. And really, it's not even the fault of the people building the tools in my mind. It's
Yeah.
in a lot of cases, the meaning of evaluation is not well defined. So to give examples, several of our customers at Aryn, they're bringing us, documents, they're bringing us queries, they're bringing us criteria, acceptance criteria. And in some cases, they've even said, okay, yeah, if you ask this set of questions on these set of documents, here's the answer you should get back. Turns out once you start digging in, you realize that in a lot of cases, in fact, they themselves don't know what constitutes the correct or the right or the desirable answer. And that's not because they're, not intelligent people. It's simply because it's not well defined. You know, show me trends associated with, these market conditions over the last 5 years. What does an answer to that look like? And how do you reason about whether it's a good answer? So if I think about, the alternative, which is I ask a data analyst or I ask a human to go and do this, generate a report on these factors, I still have to kind of trust that the person who did that work is doing things in the right way. They're not making things up, that they haven't glossed over important information, that they're not missing things. And we have a lot of implicit trust in people to do that. And, good people who have good results and so forth. So we have that kind of relationship building between people. We don't yet have that with the language model. And so how do we establish trust? Because I think fundamentally that's what it's going to come down to. I don't know that there will be a rigorous methodology in all cases. So the eval tools that are out there, I think, help to some extent, but I don't think they can answer that question. I think that's not a tooling question. That's a kind of a deeper philosophical question of, what constitutes a good answer.
Yeah, I think as a first step, the main thing is, as you've alluded to very early on in the podcast, the number of people doing AI related work has expanded. So maybe what we really need are tools that will allow people to collaborate on the eval side early on. So, for example, I don't know.
Mm-hmm.
I mean, you've got the engineers, the product people, but maybe even the legal people, all collaborating early on the eval side. Because right now, I guess people are just using Google spreadsheets to Google Docs, right? So there's no central tool where they can kind of collaborate uh, cross-functionally.
I've seen some things that start to approximate that, but I think the cross functional approach makes a lot of sense there because it's true that today, if I'm going to go run an eval, it's going to go dump out a JSON file with the results. And that's something that, an engineer can understand, but how do you get a lawyer to have confidence in this?
Right.
How does the lawyer or the product manager or the business owner of some feature iterate on that and dig in on, well, how did this come up with this answer? And I think what we're learning is, through the contact with customers that are trying to do this every day, you learn a lot about how to make it not just presentable, but just really to help them build confidence. If you're throwing JSON at them, they're not going to have confidence. But if you can give them things that help them understand what's happening, then it goes a very long way.
And the website is Aryn.ai, ARYN.ai.
Correct.
And also, you should check out the movie The Social Network, and free and pause when it gets to the lecture in the computer science hall.
If you zoom in, you'll see my name in the lower, right corner of the slides on the screen in the movie, and that was something I did in fact add to the slide deck I sent to Columbia Pictures before they filmed the scene.
And with that, thank you, Matt.
Thank you very much. It was great chatting with you.